Okay, and welcome back. And now I'm going to be giving you gold, man. Solid gold. We've hit the trifecta today. You hit the trifecta. The trifecta is we're going to do a correlation analysis, a regression analysis, and exponential smoothing, all for the price of one. So you're going to have a tremendous thing to add to your portfolio after we're finished with this. And if you wanted to do those three things manually, it would take you hours. We're going to do it in less than 10 minutes. So let's get started with the big boy. All right. So what I want you to do is turn to Chapter 9, Problem 23. And we're going to do a little alteration with it, but I just want to show you the way so you can get your interactive work assignment done. So head on over there. Again, Chapter 9, Problem 23. Pause if you want. All right. Hopefully you're back. All right. So this is about the Sunset Inn, and it's got the guests and breakfast, and it's asking you for a bunch of stuff. Now, what I did is I kind of generated a little bit more historical data. So I took the information that you can see in the book and just typed it in here and then added another year's worth of data based on an inflation increase factor. But anyway, the idea is I wanted to have a little bit more robust information here. So we have 2 years worth of data rather than one, but we can still answer all the questions. So let's just start off with the first question. It says, determine the coefficient of correlation for the Sunset Inn based on the above data. All right, so here's how we're going to do a correlation. All you're going to do is click on a cell, and I was over there. Head over to the formulas, more function, statistical, and come down and find Carl. Okay, and it's going to pop this thing up with an array. Well, array 1 is going to be our rooms, and array 2 is going to be our breakfast customers. And we just hit OK, and voila, done. So what this is saying is we just ran a correlation. How long did that take? And that's just so powerful. So what it's saying is that there's a 0.93. This is highly correlated. There's a super high correlation between the number of rooms that they rent out and the number of breakfast customers that they get. Well, okay, that's good. Now, why do we need to know that? Why would we start here? If there's no correlation, how are you going to use rooms as a determinant of breakfast customers? I mean, you can say that you want to do that, but if there's no correlation there, any forecast or any relationship you're trying to draw would be false. But in this case, we have a super high correlation. Again, when you get into like about 0.6, you find that there's a correlation. 0.8 is strong. 0.92 is incredible. So there's a high correlation there. Good, we know that. Now let's go to the next question. Determine a regression equation for forecasting breakfast customers based on the number of room guests. Okay, so now we take it to the next level. So what we want to do now is we want to be able to take this information here and find the equation. What is the regression? How does, when rooms move, how do breakfast customers move with it? All right, so what is the causal relationship here? Y equals fx. Y is a function, okay, y in this case is going to be breakfast customers, is a function of rooms. So let's go over to the data, we're going to go back to insert, and we're going to just pull up a scatter chart. And there you go. So now we're seeing that there's a relationship here between the rooms and the breakfast customers. But you see all the data is kind of like clustered together here. So let's just right-click on that axis here, on the x-axis, and then right-click, Format Axis, and you'll notice this pops up on the side. And all we need to do is say, well, we want to spread this data out because it's too clustered together. And the reason is because it's starting at 0. So we're going to make the minimum axis say, looking at the data, just say 900. And you'll notice it spreads out. Okay, so now we can see the relationship between the rooms rented and the breakfast customers. So now let's just drop in a regression line. So we're going to go into trend line, more trend line options. And I know I'm moving quickly, but you can always go back and rerun this video. And you'll see that it inserted a linear regression line for us automatically. So what we want to do is we want to display the equation and get the R squared. Okay, so what's the correlation, or how well does that line fit? So we click on this, pull it up here, and there it is. We can see that we have our regression equation here, and we can see that the R squared is again highly correlated. So this is a great line. It's a great equation, 0.86. All right, so now we know what the relationship is. Y, okay, breakfast customers, equals 1.0445x rooms plus 83.964. So now we have a predictive model of, if we know what the forecasted rooms are, we can determine what our forecasted breakfast customers are. So now we can do an exponential smoothing model to create and generate a future forecast. So let's do that right now. So all we have to do in Excel, and this is what I'm saying, we just did a correlation, a regression line with the line fit and the R squared on that, in a matter of seconds. Now watch this cool beast we're going to do here. Okay, now what we're going to do is we're going to take and make a forecast of rooms. So let's come down here and simply highlight these two columns. Go back over to data, and all you're going to do is you're going to click on this forecast sheet. Boom. What it comes up with is an exponential smoothing model for this data. Now, what we're going to do is we're going to get a little bit more precise with this thing. So let's just hit the options, and let's just go all the way out. Let's just change the forecast time, and let's go out for a full year, okay, because this ends on 12/1. We're going to go to December 1, 2020. And now normally what happens, you'll notice right down here, it has a seasonality, and it's trying to auto-detect. Now normally this works really well, but for some reason this data isn't providing it a pattern it can see. So we're not getting a really good forecast. This line here is your central tendency forecast, and this is your zone of probability. And you're going to see how powerful this is in a minute. So let's break this down a little bit. So we're seeing here that our forecast is ending on 12/1/20, started on 12/1/19, providing us with a 95% confidence interval. That's what these ranges are here. And what we're going to do is we're going to change that to a manual detection. Now, I can tell you for your interactive assignment, just use the auto detect. The data that's in there it works beautifully. But for here, if it's not sensing a pattern, we can create and tell it what this pattern is. And we're saying that we want a 12-month pattern. Now you can see as I move up the scale of months here for the pattern, you'll notice that all of a sudden the zone of probability, okay, what's the high and low possibilities with a 95% confidence that we're accurate, is being generated. So let's go all the way to 12, and you're going to see, boom, there is actually a perfect exponential smoothing model with a very, very high degree of accuracy. So let's just go over here and click on this and create. And what it does is it creates a sheet for you and shows you the forecast out for the next 12 months. Okay? Now let's come down here and read this. You'll notice that it made a duplicate of the historical data all the way back from 12/1/18 all the way through to 12/1/19, and then it does the forecast. It's created a forecast, and this is the cool thing about this, okay? Not only do you get this cool little model over here, but it also gives us a probable, the central tendency, the most probable forecast for January, February, March, etc. Also, it's giving you the lower range and the upper range. So you could go to your boss and say, well, this is what we think it's most likely going to be in March. This is what we think it's most likely going to be, or least likely to be. In other words, what's the lowest possibility? And then this is the highest possibility. So it's telling you the most probable, let's call it worst case scenario, best case scenario, with a 95% probability that you're right. How cool is that? Okay, so now let's just take this data right here and copy it, because this is our forecast. And we're going to copy, go back to our original sheet, and now we're going to add this to our model. Now, it's really important when you paste this, you don't want to paste it like that. As you notice, you get a reference, because it generated what's called a pivot table, and we're not going to get into that now. So make sure you just do 1, 2, 3, which is just the values. You click on that, okay? And sometimes you may need to round it to get rid of the decimals and so forth, but in this case it worked fine. Now all we're going to do is, again, we're going to take this little pattern here, draw it down, okay? And there is our forecast, okay, of sales for 2020. Now we come back and we see that we have our regression, our forecast for the breakfasts. So let's just insert this equation, and all we're going to do now is hit equal, and again, this is coming from over here, all right? 1.0, we'll call it 45 just to make it simple, okay, times, and then we're going to do B 28, and then it's going to be plus, we'll just call it 84. And there you have it. There's your forecast. Now, we're going to copy this down, okay? So all we're going to do at this point is just drag this down here, and there you have it. There's your forecast for every single month for breakfast customers for the year 2020. There you have it. So again, there you have your regression equation, your correlation analysis, and there's your exponential smoothing, all done in a matter of minutes. Don't forget to add this to your portfolio and show it off to your boss or your future employer. Good luck.